Welcome to this comprehensive guide on data persistence in Unity, designed specifically for beginners. Today, we'll explore two fundamental methods, player prefs and JSON serialization, which are crucial for saving player progress and game settings. Understanding these techniques is essential for creating engaging and functional games that retain user data across multiple play sessions. Data persistence is vital for any game, allowing information like high scores, player inventory, or configuration settings to be stored and retrieved across different play sessions. Without it, players would lose all their progress every time they close the game, leading to a frustrating and incomplete experience. First, let's delve into player prefs, Unity's built-in system for storing simple data. It's perfect for basic game settings and player preferences due to its ease of use and minimal code requirements, making it an excellent starting point for beginners in data persistence. Player prefs operates on a key-value pair system, where keys are strings and values can be integers, floats, or strings. This makes it straightforward for storing individual pieces of information, such as a player's high score, music volume, or their chosen player name, in a simple and accessible format. To save data, we use methods like playerprefs.setInt, playerprefs.setFloat, or playerprefs.setString. Each method takes a string key and the corresponding value, allowing you to store different data types efficiently. For example, playerprefs.setInt saves an integer value associated with the key high score. After setting your preferences, it's crucial to call playerprefs. Save to write these changes to disk, ensuring your data is permanently stored. If you forget this step, your changes might not be saved, and the data could be lost when the application closes. Loading data is just as simple, using playerprefs.getInt, playerprefs.getFloat, or playerprefs.getString. These methods require the key and an optional default value. For instance, int highscore equals playerprefs.getInt attempts to retrieve the high score, providing a default of 0 if it's not found. The default value is returned if the specified key does not exist, preventing errors and ensuring your game functions smoothly even without prior saved data. This is a robust way to handle scenarios where a player might be launching the game for the very first time. You can also verify the existence of a key using playerprefs.hastkey, which returns a Boolean value, allowing for conditional logic in your game. This is useful for checking if a specific setting has been saved before attempting to load it, preventing potential issues. Let's see a quick demonstration in Unity. Here, we have a simple script that saves and loads a high score using playerprefs. This practical example will illustrate how these methods are implemented within a Unity project, providing a clear understanding of their application. When we run the game, we can input a score, save it, and then load it back, even after restarting the application. This illustrates the basic functionality of playerprefs, demonstrating how data persists across different play sessions, which is fundamental for any game. While convenient, playerprefs has limitations. It's not suitable for large amounts of data or complex data structures, and the stored data is not secure. This means it should only be used for non-critical information that doesn't require high levels of security or intricate organization. For more robust data persistence, especially with complex data, we turn to JSON serialization. JSON, or JavaScript Object Notation, is a lightweight, human-readable data interchange format, making it an excellent choice for structured data storage in games. Unity provides built-in support for JSON through JSON Utility. To use it, you first define a C# class or struct representing your data, marking it with System Serializable. This attribute is crucial as it tells Unity that this class can be converted to and from a JSON string. This attribute tells Unity that the class can be serialized, allowing its public fields to be converted into a JSON string. It's a fundamental step in preparing your custom data structures for persistence using JSON, ensuring that all relevant public data can be saved. To save data, you create an instance of your data class, populate its fields, and then use JSON utility.toJSON to convert it into a JSON string. This method efficiently transforms your C# object into a textual representation that can be easily stored or transmitted. This JSON string can then be saved to a file using system.io, file.writeAllText, typically in a platform-independent location like application.persistentDataPath. Using application.persistentDataPath ensures your save files are stored in a location that is appropriate for the operating system, preventing compatibility issues. Loading data involves reading the JSON string from the file using system.io, file.readAllText, and then converting it back into your data object with JSON utility from JSON T. This process reconstructs your C# object from the saved JSON string, restoring all the previously stored data. Let's demonstrate this in Unity. We'll create a script that uses our GameData class to save and load player information. This example will showcase the practical implementation of JSON serialization, allowing you to see how custom data structures are handled. When we run this example, you'll see how player score, health, and name are saved to a JSON file and then accurately reloaded, maintaining all the data. This demonstrates the power of JSON serialization for handling more complex and structured game data compared to player prefs. A key advantage of JSON is its human readability. You can open the .json file in a text editor and easily inspect the saved data. This makes debugging and understanding your saved game states much simpler, as the data is presented in a clear and organized format. However, JSON utility has limitations, such as not serializing private fields or properties. For advanced scenarios, third-party libraries like JSON.NET offer more flexibility and features, allowing for more intricate serialization needs beyond Unity's built-in capabilities. Also, because JSON files are human-readable, they are not inherently secure. Sensitive data should be encrypted before saving to prevent easy modification. This added layer of security is crucial for protecting player data from tampering or unauthorized access. When choosing between player prefs and JSON, consider the complexity and security needs of your data. Player prefs is ideal for simple settings and preferences, while JSON is better suited for structured and larger datasets that require more organization and flexibility. Always use application.persistentDataPath for file paths to ensure your saved data is stored in a reliable, platform-specific location, avoiding issues across different operating systems. This ensures that your game's save files are accessible and compatible regardless of where the game is played. Implementing proper error handling is crucial for both methods. This prevents crashes and data loss if a file is missing or corrupted during loading. Using try-catch blocks around file operations can gracefully manage these situations, providing a more robust user experience. For highly sensitive data, consider encrypting your data before saving it. This adds a layer of security, protecting player information from unauthorized access. Encryption transforms your data into an unreadable format, making it secure even if the file is accessed by malicious users. Beyond player prefs and JSON, Unity offers other advanced persistence methods like binary serialization, databases, or asset store plugins for even more complex game requirements. These options provide greater control and scalability for games with extensive data management needs. Mastering data persistence is a fundamental skill for any Unity developer. By understanding player prefs in JSON, you're well on your way to creating more engaging and robust games that can save and load player progress, enhancing the overall player experience significantly. Thank you for joining this tutorial. Keep experimenting with these techniques to build amazing experiences in Unity. We encourage you to practice these methods and explore their full potential in your own game development projects.